welcome back to chemistry. Today we're going to be talking about a special type of ionic compound, acids. Now acids are ionic compounds. They do break apart into ions. They form a cation and an anion as soon as they gain and lose electrons. So today we're talking about naming acids. So just like I said, these are ionic compounds. Okay. Now, how do you know if you're dealing with an acid? Okay. Very simple. All acids start with a hydrogen. Okay. All acids start with a hydrogen and they're connected to a nonmetal. Really easy to recognize. All acids start with the H and they end with the nonmetal. So when we talk about today naming acids, it's actually easier just to do examples. So I'm going to give you a couple of examples here. The first example we're going to look at, example 1, we're going to look at HBr. Okay. And then example 2, let's look at H2CrO4. Okay. So these will be our two examples because it gets a point, the two things we got to look at when naming acids. So remember, acids start with an H. These two guys start with an H. That's how we know they're acids. And they have a nonmetal. Well, because all acids have hydrogens, they start with this H. We don't worry about naming the hydrogen. They all have the hydrogen, so we don't care about it. So all we care about is what happens after the H. Okay? What happens after the H? We have two options here. Okay? Two options. We have a single nonmetal, or we can have a polyatomic. We have a single nonmetal, or we can have a polyatomic here. Okay? Now guys, everything is staying the same. This guy is an ionic compound. The hydrogen is going to give up his electron. The bromine is going to take it. Hydrogen is going to form the cation. Bromine, because he accepted the electron, is going to become an anion. So everything stays the same as if regular ionic compounds. The same thing happens in solution. We form these solutions. All the ions, the molecule breaks apart. You have these pluses, you have the minuses, and we have a solution full of pluses and minuses, ionic. It conducts electricity, right? I'm just giving you this back information. It conducts electricity. They're called electrolytes, electrolytic solutions. Okay? So, acids act the very same as regular ionic compounds. Okay? So let's talk about naming the single nonmetal here. Okay? Very, very simple. First of all, we don't care about the H. Let's get that out of the way. They all have H's, but the single nonmetal. You're going to look up the single nonmetal. In this case, this guy is bromine, right? If it's a single nonmetal, he gets the hydro on the front, and then you're going to put ic on the back, and then you just write out acid. Okay? So we put hydro on the front and ic on the back. So let's name this acid right here. Bromine becomes hydro bromine becomes bromic, and then we just write acid. Hydrobromic acid. Hydro on the front, ic on the back. And just so you know, if you look at your list of nonmetals, fluorine turns into fluoric, chlorine turns into chloric, bromine turns into bromic, iodine turns into iodic, oxic, sulfic, selenic, nitric, phosphoric. They all just take the "ide" ending, okay? Really, really simple. Now let's look at polyatomics, okay? Same thing with polyatomics. We don't care about the H. What's happening after the H? So we're going to look. Oh, look, there's more than one element. That's a polyatomic, right? So we see it's a polyatomic, so we're going to go to our list of polyatomics, and we're going to find CrO4. So let's do that now. So we see that CrO4 is chromate, right? So keep that in your head, chromate. And if you look on the list, guys, there's two basic endings to all polyatomics. They end in ate and they end in ite. Okay? Those are our two basic endings for polyatomics. They don't end in ate or ite. You treat it the same way as ate. Okay? Now pay attention to this part, right? If it ends in ate, you're going to turn the ate into ick and then say acid. If it ends in ite, you're going to turn the ite into us and then say acid. Okay? Now, one big caveat here, and I'm going to write this because this is super important because everybody always tries to do this. There is no hydro. We do not write the word hydro when we're dealing with polyatomics. Okay? So, let's name this polyatomic. He was chromate. Chromate, it ends in ate. So what is it? What do we turn that ate into? Ick. So this guy, chromate, becomes chrome-ick, and then we write acid. So he is chromic acid. But we don't write hydro because we're dealing with the polyatomics. We only write hydro if it's a single nonmetal after the H. Okay? So let's recap. We don't care about the H because they all have H's. They start with H's. That's what makes them acids. If it's a single element after the H, we put hydro in the front, back, and then say acid. If it's a polyatomic after the H, we look up the polyatomic. We change his ending. If it's ate, it turns into ick. If it's ite, it turns into us, and we don't write hydro. And then we just write acid. A good way to remember the polyatomic rule is this. I ate something and got sick. I ate something and got sick. Ate turns into ick. I got in a fight to protect us. I got in a fight to protect us. Ite turns into us. That's a good way to memorize it. Okay? So let's work some examples here just to make sure we got these rules down. Okay? And we'll slide this up all the way to here. So let me give you a couple examples here. Let's say we had HCl. We're going to use this example. Is this an acid? Yes, it starts with an H. Now, which rule are we going to use? Rule 1 or Rule 2? We got to choose. Well, after the H, it's just a single nonmetal. So we're going to use rule number 1. So what do? We're going to write hydro. Hydro, right? This is chlorine. We're going to look it up. His name is chlorine. So chlorine turns into what? Chloric. And then we write acid. So his name is hydrochloric acid. Really simple. Another example would be, let's say, HNO2. Okay? Is this an acid? Well, let's look. Does it start with an H? Yes, it does. What's after the H? Which rule are we going to use? Well, there's more than one element. The word for more than one element is polyatomic. So we're going to use rule number 2. So now you're going to go and look at your list of polyatomics. Let's do that now. So you're going to see that NO2 is what? Nitrite, right? Are we going to write hydro? No, we don't write hydro, right? So nitrite turns into ite, turns into us. So this is nitrous. Not too hard, right? Let's do another example. HNO3. Okay. Try to pause the video and guess this one. Okay. First, it's an acid because it starts with an H. We're going to look. Single or polyatomic, we can see it's a polyatomic because there's more than one element. We're going to look up the polyatomic. Let's look it up. we see that it's hydro I mean, we're not going to write hydro, but nitrate, what is it turn into? What is So really simple rules, guys. We don't care about the H. We care about what happens after the H. Singles get the hydro on the front, ick on the back. Polyatomics, no hydro. 8 turns into ick, and ite turns into us, and we just write acid. Really, really simple. Thank you, guys, and have a great day.